Look at it, a colossal wall of concrete holding back a lake the size of a small country. The water roars through spillways, a controlled fury that could power a city. It's a breathtaking sight, a testament to what we can build. But as you stand there, staring at that immense pressure, a simple, nagging question pops into your head. How does that thing not just break? All that water, millions of tons, pushing, always pushing. Yet the wall just stands there, year after year. This isn't just a barrier, it's a carefully balanced equation of physics and force. On one side, the relentless energy of a river. On the other, human ingenuity, shaped into a curve of concrete and steel. The dam is an active participant in a high-stakes standoff, a silent guardian that must win every second. The consequences of failure are almost too terrifying to imagine. So, what's the secret? Is it just brute force? Not quite. The real answer is a mix of brilliant engineering, hard labor, and a deep respect for the power you're trying to contain. It's about understanding the forces at play and using them to your advantage, turning the water's own weight against itself. We're going to pull back the curtain on these modern marvels and the people who build them. These structures are more than just concrete. They are a legacy of human ambition and responsibility. Let's get into it. Let's talk scale. The Hoover Dam contains enough concrete to build a highway across America. The Three Gorges Dam in China is over a mile long and 600 feet high. These aren't just buildings, they're man-made mountains. The weight of the water behind these dams is so immense it can even slow the Earth's rotation by a fraction of a second. The pressure at the base of a tall dam could crush a submarine. If a dam fails, it's not a leak, it's an apocalypse. A wall of water hundreds of feet high would obliterate everything downstream. That's why these dams are obsessively engineered and monitored. The margin for error is zero. Every calculation, every weld, every batch of concrete must be perfect. The people who build these things are guardians against catastrophe. They're building something designed to last for centuries. A silent sentinel that must always be flawless. It's a heavy burden, as heavy as the concrete they pour. The stakes are as high as the structures themselves. This is engineering at its most extreme. How do you even start? First, you need the perfect spot. Geologists search for a narrow canyon with strong, stable bedrock. No faults, no fractures. The canyon walls must bear millions of tons of thrust. Once the site is chosen, the river must be moved. Workers blast massive diversion tunnels through solid rock big enough to drive trucks through. Temporary cofferdams block the river, forcing it through the tunnels and leaving the riverbed dry for the first time in millennia. Then, excavation begins digging down to solid, unweathered bedrock. The foundation must be perfect. Every crack is cleaned and filled with grout to create a single monolithic base. The dam is keyed directly into the bedrock, making it one with the earth. Any weakness here could be catastrophic years later. It's painstaking work, but it's the most critical step. With the foundation ready, it's time for concrete. You can't just pour it all at once. The heat from curing would crack the dam, so engineers pour the dam in blocks like a giant Lego set. Each block is poured, cooled, and then the next is added. To speed cooling, they embed miles of steel pipes and circulate freezing water through them. A massive refrigeration system inside the dam. Overhead, cableways deliver giant buckets of concrete day and night for years. Workers, called puddlers, spread the concrete, making sure there are no air pockets. As the wall rises, a shape emerges, the arch dam. The curve isn't just for looks, it redirects the water's pressure into the canyon walls. The stronger the water pushes, the tighter the arch wedges itself into the rock. It's a design of pure genius, using the enemy's strength to make the dam stronger. This isn't just a wall, it's a tool of physics. Every block, every pour is a step in a colossal balancing act. So the dam is built, a massive curved wall of concrete. Why doesn't it break? The arch shape transfers the load to the canyon walls, but gravity is key too. Gravity dams rely on sheer mass. They're so heavy, water can't budge them. But here's a secret. Dams are designed to move just a little. The Hoover Dam flexes at the top, swaying inches as pressure changes. This slight elasticity prevents cracks and adds strength. Inside, dams are laced with tunnels and galleries for inspection and drainage. Water inevitably seeps in, but drains channel it away, preventing dangerous pressure buildup. Sensors monitor everything: water pressure, stress, movement. Plumb lines detect any tilt. Inspectors and divers check for trouble. A dam is never just finished, it's under constant high-tech surveillance. Every day, teams ensure the giant remains healthy and strong. It's a living structure, always adapting, always watched. The secret strength of dams is vigilance, flexibility, and relentless maintenance. That's how these giants endure. With all this engineering, you'd think dam failures are impossible. They're not. Major failures are rare, but when they happen, the results are catastrophic. The St. Francis Dam disaster in 1928, a collapse, a wall of water, over 400 lives lost, caused by unstable geology. The Vajont Dam in Italy, 1963, the dam held, but a mountainside collapsed into the reservoir, creating a mega tsunami that killed nearly 2,000 people. These tragedies taught engineers to study not just the dam but the entire environment, geology, slopes, everything. Every failure is studied, every lesson learned. Modern dam safety programs are built on these hard lessons. The thought of failure drives the industry to be better, safer, more vigilant. Engineers know they're responsible for every life downstream. That responsibility is built into every calculation, every inspection. The rare stumbles of these giants have made today's dams safer than ever. We honor the past by building a safer future. A massive dam isn't just concrete, it's a monument to human ambition. It's a testament to the engineers who harnessed nature's power and the workers who risked everything to build it. These structures turn destructive force into life-giving water and clean energy. They transform deserts into farmland, provide water to millions, generate electricity, and prevent floods. For all the debate about their impact, their positive influence on civilization is undeniable. They are the workhorses of our infrastructure. Next time you see a dam, look past the concrete. See the story, the minds that designed it, the hands that built it, the eyes that watch over it. These are more than feats of construction, they're symbols of what we can achieve. Proof that with knowledge, courage, and resolve we can move mountains. That's the legacy of the giants. If this blew your mind even a little, give it a like. And if you're into the hidden genius behind everyday wonders, hit subscribe and stick around for more.